you can implement the PetriNet simulation in about 10 lines code. I mean, the whole thing comes down to about that. And the other 80,000 lines of Java code is graphics user interface. But the thing is, with this, you can also write the notion of a pattern. When he refers to a pattern, basically it's a predicate on a set. Think of, so a PetriNet is a set of transition assertions like this. So a PetriNet, so every line that you see there is translated into an assertion like this. A pattern is simply a set of these with variables in it.
That's fine. Yeah,
That's it. And you can match any, and the variables can go anywhere. And the variables can even range over multiple transitions. So you can have patterns that match something up here and something down here. And connectivity in the PetriNet is following the path through the input and output.
that's no problem. My question is, from which to which? From patterns to this, or from this to patterns?
Look, I think this picture explains clearly your question. Okay. The input, this is the deontic from set model. This is the input. And this is the pattern. You see, this is the pattern. It looks like a segment or fragment of the models that commonly appear in many different models. So the pattern will load on the deontic process, and there is a pattern matching. There's a pattern matching. This kind of thing has been predefined. If this pattern, then there are two rows involved. And what is risk of the first row, what is the risk of fraud of the second row, and what is the control requirement to prevent this kind of thing. So you can import many different kinds of deontic process model in many different ways, but as long as the pattern matching here, then the control requirement come up.
So could we say that what's coming in is the deontic process model? So the input is this,
and the deontic patterns.
and the deontic patterns.
Output is the control requirement.
Yeah.
Into Boo's black box, Boo BB, and out comes your control goals.
Yeah, actually it's right here. It's right clearly here already. It's right
Are you in agreement with what I just did?
exactly this picture.
Okay, so then number 5 is, I thought you want to get the set of models. That's
No.
one.
The thing I do here, I put it in the bottom. I set a model to validate the methods here, to demonstrate the set of constructs is enough.
Okay,
or not.
so that's
I want to
just
validate
This is
the
kind
thing
of
here.
like extra credit.
So this is a full validation. This is not the
first three
goal.
Yeah, it's like showing that okay, it's working.
Okay, I see.
Yeah, I put a line here already. I put a line
So
here.
you don't deliver a set of models.
1, 2,
Yeah.
and 3 are really important, and 4 and 5 are things you do to show it off.
So 1, 2, 3 is the theoretical contribution, and 4 and 5 is the example.
Yes, that's right. The line is here. The cutoff is the thing here. The object is there.
And then you have that sheet, the left-hand side, this is the right-hand side, they 1, 2, 3, right?
Yes,
You
1,
have
2, 3
the
is the right hand side.
Okay, and can you go back? So what's the relation between the left and the right? That's what I mentioned in the mapping.
That is about the left. This is about the right. The first one is about the right. The control, requirement, reason. And this is about the left. The deontic process model. And the objective of the research is about, mainly is about the right hand side. Develop a formal method for reasoning about control requirement.
So as I said, the mapping, actually there's no mapping.
There's no.
No mapping. Okay.
That's why you don't really objected the term mapping and mapping. in the very beginning.
Okay.
Because, the mapping is not-
So the connection is just the pattern. You have this, given this, you try to see whether there is certain patterns. So you don't derive it from it. There's no derivation, right?
The pattern is already there.
Yeah, the pattern is already there.
Right, right. But when you do,
But you have to build those patterns from your domain.
right, so what you need to do, you need to look at the domain, you need to model many samples, so you see what it commonly happens.
So in order to be able to validate and really work with your 1, 2, and 3, you need to have something, a data set to work with. And that data set
Maybe saying that these are the kind of things, these are going to be your The main thing you're going to show us is a bunch of these.
Yes, sure. This is the first thing. This is the first
And then your
priority.
claims about these.
Yes, this is the first priority.
These kind of rules with the pattern example.
Yes. Yes, this is the first priority, it's the principle. Of course, in order to come with the principle, we need to look at the domain. And look at the domain actually in the can try to model several things and see what is the common thing that occurs in different domains, different models. And I see there are certain models like that, certain domain, pattern like that.
Are we ready to have him take the walk? If you go to Venice, there is a certain bridge, it's called Ponte di Sospiro. It's like it's the bridge of sighs.
Which bridge?
It's the bridge that connects the courtroom to the jail.
The last thing of business.
So you see the condemned prisoners go across the bridge. And the mothers used to stand outside and see their sons go across.
So is there is such a bridge, right?
There is such a bridge.
I don't know. I went to there once, but I don't know what I walked over there.
It's just outside the Piazza San Marco. You go to the station.
Oh, that's the one.
It's behind the palace. Behind the-
I might have walked down.
We don't know it that.
So, okay, everybody out except the committee. Don't go far away.